So this is going to be a slightly different presentation than some of the other ones. I'm going to just focus on pre-confirmations, but also talk about how we leverage libp2p. So let's dive in, right? So what are pre-confirmations? We define them as a credible heads up before a confirmation happens. And we believe this definition applies to beyond blockchains. And the prominent, I'm actually going to put this down.
Use it for the recording.
Is that better? Yeah. Okay. So the prominent example here is Amazon, right? So when you buy a pack of razors, whatever, from Amazon, Amazon's credible heads up is enough for you. You don't need USPS's word. You don't care if it's FedEx delivering. But Amazon's heads up is so credible that it's good enough for you. So this definition changes how people think about pre-confirmations when it comes to the proposer monopoly on Ethereum. The traditional thinking was that the proposer is going to need to provide the service because the proposer is the deliverer of the pre-confirmation or the confirmation at the end of the day. However, we take this kind of Amazon USPS model and create this kind of fulfillment-focused model so that specialized actors can fulfill pre-confirmations that can be delivered by proposers that just opt into the protocol. So we go over 4 types of pre-confirmations. Transaction pre-confirmations, I guess you guys can figure that out. State is an interesting one. So you're pre-confirming a state tree on Ethereum over a particular transaction that can then fill in the details for that state. Block pre-confirmations are pretty interesting. So you can kind of have an anti-MEV boost auction where the block is pre-confirmed early into the slot for some amount, and then the details get filled in. And finally, we have slot auctions where some future slot can be auctioned off, and whoever has that basically has the rights to create a block for that slot. Now we're going to focus on transaction pre-confirmations here. And I gave this example about USPS and Amazon, and it's a pretty strong one, I believe. And at the end of the day, we don't want a single Amazon on Ethereum doing all pre-confirmations, but we want specialized actors like Amazon to come in and compete to offer the users the best pre-confirmations. So we introduced a fulfillment consortium model that does not require validator participation. By adding every single, a majority of the actors of PBS on Ethereum to a peer-to-peer network, we can allow you to coordinate with them on confirmation. And this does not require validator participation, so it's a very strong model. So basically, today, the scheme is that you send some transactions to Ethereum, then you wait 12, 15, 16 seconds, and then you find out whether they got executed or not. So you have this problem of unknown execution risk. This fulfillment consortium model allows you to know your execution risk. So if you create a pre-confirmation bid and send it to this network, block billers comprising, let's say, 80% of the network power can give you commitments, and in real time, you're aware that 80% of the network is guaranteed that this is going to happen. So you can plug that 20% known execution risk number into your risk algo and then hedge whatever else you're doing with this trade or why you need that execution. We note that once we add the proposer to this, it becomes an ultimate credible commitment. So once you know that the proposer is also involved and he will definitely deliver these commitments, then you can basically get real-time pre-confirmations on Ethereum for all use cases, pretty much. So how do we achieve MEV boost style transaction pre-confirmations? 2 things. 1, a peer-to-peer network for fulfillment and delivery. All these actors can join a peer-to-peer network. And then 2, you need a different chain to play these fast games, they're called. So fast games are defined by Barnabé from the EF as games that by construction the chain does not have access to. So Ethereum has 12-second, 15-second blocks, and during those blocks you can't enter into these faster than Ethereum games. So we introduce MEV commit for this. MEV commit is a purpose-built chain for this. However, what's interesting about it is that it's abstracted from the peer-to-peer network. So the peer-to-peer network can decentralize on its own and have these real-time bids and commitments about pre-confirmations happen, while a high-throughput, right now centralized chain will settle them, and in the future we'll decentralize that as well. So this is the introduction of MEV commit, and it's available on Holsky testnet. How do we use libp2p? Well, we knew we wanted to do P2P because our origination story was that I was a lead product manager at a major block builder, and that we could not give next block execution, even though we had 20% market share, 80% of the time. So you need this network of block builders that you want to interact with. You don't want to interact with a single block builder because they can't give you any credible guarantees. So using P2P in general, and then obviously using libp2p became the aspect through which we accomplished this. And then we have some fancy encryption on the network that also solves for privacy and whatnot, but I'm not going to focus on that in this presentation. So we get a lot of properties from libp2p. And this was very important for us so that we don't spend our time building a networking stack from scratch, but we can really focus on our pre-confirmations layer. So we've opted to go with a directed P2P over gossip. So it's kind of a one-to-many direct TCP connections. And this allows for you to do things in a latency optimized way. However, because we use libp2p, we can move over to gossip for other use cases very easily in the future. And then we use a mesh topology, the handshaking and the peer discovery protocols of libp2p got us started. And then obviously this approach allows you to resist man-in-the-middle attacks because it's not the same as direct connections that can be spoofed. And then we do have gossip-related use cases in the future. So we'll be able to quickly enable those because we use libp2p. Now a MEV commit node is quite different than most blockchain or kind of network nodes. It has two roles. It has the bidder role that allows you to send bids and receive commitments in real time. It also has the provider role that has some specialties that allows them to kind of see some of these bids and kind of react to them and provide these commitments. Providers have some ETH staked, so if they break their commitments, the ETH gives the commitment some credibility on top of their reputation. But if they break the commitments, then we can slash them and return funds to users. What's also different about MEV commit is that it does not make assumptions about who the bidders and providers are. We actually introduce a model where anyone in the MEV pipeline can be a different actor depending on who they're interacting with. So you might have a block builder who is a provider for a rollup, but a rollup might be a provider of a pre-confirmation for their own users. And similarly, a rollup might be a bidder for an L1 block builder, but like I said, it could be a provider for somebody else. So depending on your role in the MEV pipeline, you are a different actor on this network. So we identified pre-confirmations as a new transaction type, and we had some research about this where we said it can improve EIP 1559, and to our surprise, the authors of EIP 1559 agreed with us. And what's fundamentally different about this is that it introduces a third field into the transaction. So today you have max fee and priority fee. These are not time-dependent fees. And for the first time, we introduce an out-of-protocol third gas field that is time-dependent. And that's because time is money. And we have a decay mechanism that allows actors to, in real time, decay the bid amount on the pre-conf bid. This incentivizes the providers to commit to it immediately over waiting till the end of the slot and spoofing the whole game. So what happens through this process? You send a bid, you get some real-time commitments from the actors on the network, some magic happens, and then you profit. What really goes down is a whole bunch of MEV actors try to fulfill this commitment, right? So they need to build a block that contains that transaction in the most profitable way, and they need to deliver it to the relay. The relay has to check it. It needs to be valid. All of this jazz that happens for things to go on Mainnet, right? So we abstract all of that from the user and also for most providers on the network. And then in the case that the commitments aren't delivered, then they get slashed. What's very interesting about this scheme is EIP 4844 introduces a whole new game here. Now, we're, I think, one of the first startups to characterize blobs as Ryu from Street Fighter, and not some actual big blob walking around. And that's because we've discovered a superpower for blobs. And I'm going to get into it now. What's very interesting about blobs in EIP 4844 is that they impact block latency. And this is not a topic that's talked about, but we've published some research on this recently, and it's been picking up across the ecosystem. So what's the uncomfortable truth regarding EIP 4844 blob transactions is that they are very large, and they add a lot of size to a block, which affects its propagation time and validity, potential validity. And they only pay a little bit, practically a few cents to do this. So from a block builder's perspective, when there's a lot of MEV going on, you don't really want to include blobs and take that risk to slow down your block to just make 20 cents. And this is kind of how it actuates. This is a diagram from Terrence, head of Prism Labs on ETH Research. So you end up having these blob sidecars that propagate in different times because of their sizes, and this can lead to missed slots because you don't know when they're going to come. And then we also show from our research that blobs take up a lot of the block actually for very little value. And then the size difference of having a blob in your block is pretty major actually. What's new about EIP 444 is that it also does not have a direct priority fee per gas. So the priority fee from EIP 1559 kind of gets stuck in the type 2 area of the transaction. And you have this new field that's max fee per blob gas, but it acts more like a base fee than a priority fee. So you have to get really fancy and build your own thing to be able to express a priority fee. But if you have a pre-confirmation, then the block builder can get that fee in real time, and you can actually update a pre-confirmation bid in real time. You don't have to resend the transaction. So it's very different than how you would speed up an Ethereum transaction, which doesn't let you do things in real time. You have to send the transaction over and over again, and then the previous one might go through. But because you have this out-of-protocol network where you can communicate with execution providers, now you can update your bid in real time. And we have this kind of cool GIF where the blob has to fight the MEV. And we demonstrate that it uses a pre-conf to do that. And we believe without the pre-conf, most block builders will opt to censor blobs from their blocks in times of high MEV activity. So yeah, MEV committed pre-confirmations are live on Holsky testnet. We're working with block builders, relays, proposers, all sorts of folks. And we believe it unlocks a new design space for app developers and protocols that can build real-time applications on top of using such an infrastructure. We have an Explorer where we have a few people that are testing the software right now. When major block builders come, and they are coming, we're very close to them, the activity is going to pick up, and we're going to be able to demonstrate some of the effects of pre-confirmations in more real-world settings. But right now we have about 8% of Holsky validators that are starting to opt into this network. To go over things, MEV Commit is a real-time P2P network for pre-confirmations and more, and there's a chain that allows you to play these fast timing games. If you want to learn more, here's a QR code where you can scan things and read about our docs or reach out to us and read about some of our latest research. But yeah, we're very excited that our use of libp2p got picked up by the team, and that we're here to talk about it. And even though we're making small use of it today, it will increase as our use cases increase in the future. And yeah, we're very excited to bring this to everyone. Thank you, guys.